Hello, pre-calculus, and we're back. Hopefully you just changed right over to the second video, but we were talking about infinite geometric series. So we're multiplying over and over and over on our sequence, and then we're adding up all the terms. Okay. For our purposes, we are going to break this into two categories. One where what I'm multiplying by each time, the common ratio, is bigger than 1. That would be like our first one, the very first thing I showed you, times by 2, times by 2, times by 2, over and over and over. And then the second type is where the absolute value, because this happens with positives and negatives, is less than 1. So now we're talking about multiplying by a third, and then a third, and then a third. Something different happens here, and let's take a look at it. So first we'll talk about the first one, and the first one isn't hard to imagine. Here's a sequence. I'm starting at a half, and I'm multiplying by 2 over and over and over forever. We're talking about infinite now, and I'm adding them all up. Well, if I'm making the numbers bigger every time, I'm doubling them and then adding, hopefully it makes sense that this thing is going to blow up. This thing's going to go to infinity. At 8, 16, 32, 64, and adding these up. Each time that this number that I'm adding is getting bigger, so when I add them, that's just going to keep getting bigger. Okay, it goes to infinity. It gets big. Okay, now the other type, though. Here's the other type. How about starting at 20 and multiplying by a half each time? So I'm cutting in half each time, multiplying by half, and adding them all up. Okay, this isn't like this one where each term is getting bigger when I'm adding. This one, each term's getting smaller and then I'm adding, and then smaller and then I'm adding. I made a little spreadsheet for you. So let's take a look at the spreadsheet. This is something I would have had you guys do if we were in class. We were not able to do this, but it's a good little activity, practice using spreadsheets and numbers and things. So here's the sequence. These are my term numbers. So the first term, second term, third term. It's said to start at 20, and then for this one, I'm going to put in a formula. So I tell Excel, look, I want this to equal the term above it, the previous term, times by 0.5, right? We're timesing by a half over and over and over. And then I've already programmed this cell to add up all the terms. So let's see what happens. Okay, so the next one is 10. I add them up, 30. Okay, so what I can do now is drag this little magic black box and do it again. Okay, 35, do it again. 37.5, do it again. Okay, so we're adding these. These would be the sum of the first 5 terms of that sequence, 38.75. But what if I did 10 terms? 39.96, already pretty close. How about 15 terms? Even closer. We're going to infinity with this, right? Each time I'm multiplying by a half, what I'm adding is getting smaller, so it's not going to blow up. Let's take it to 40, not even infinity. I'm taking it to 40. And Excel can't even differentiate anymore. It's saying, look, that is really, really, really close to 40. And it is. Okay, as I keep adding these little tiny pieces, this number, this sum, is going to approach 40 for our particular sequence. So if what I'm multiplying by is, I don't want to say a fraction, but is less than 1, the absolute value of it, then when you add up all these terms, it's actually going to approach a number. We're going to get a number answer for this, and it happened to be 40 for this one. Okay, so I want to do a quick examination of the formula, and then I'll send you on your way. Here's our SN formula for a series, for a geometric series. We have our first term, 1 minus r to the n. If r is bigger than 1, right here, right? That was our first one. If r is bigger than 1, hopefully we can see that I'm doing 2 to the nth power. Okay, and then 1 minus that and 1 minus that. That's not a big deal, but 2 to the 5th power, 2 to the 50th power, 2 to the 5,000th power. It just gets too big, overflow. Boom, right? It blows up. And I'm adding these up. But if r is less than 1, like a half, well, let's see, a half to the 5th, a half to the 50th, a half to the 5,000th. It gets so small, it goes to 0, it approaches 0, it gets to 0. As we let n go to infinity, right, an infinite sum, this piece of the formula just falls off. That goes to 0, 1 minus r to the n, 0. So now we're just left with a1 times 1, a1, over 1 minus r, and that's it. If you want to add up all the terms of an infinite geometric series, geometric sequence, then we just need to know what the first term is, and we need to know what r is. We can put it in this formula, and that will add up all the terms for us. Okay, let's do one example and be done with this. Here we go. Here's a sigma. The partial sum, kind of. We're going from 6 to infinity this time. Here's my sequence. I know it's geometric because it's a base raised to some variable power. All the other things are kind of bells and whistles. It's geometric and it's infinite. So I'm thinking this formula we just looked at, geometric and infinite. Okay, in this formula, A1 is the first term of our sequence. It doesn't mean plug in a 1 all the time. It means plug in whatever this bottom number is. This will be the first term of my sequence. So I'll come up here and I'll plug in a 6. 6 minus 1, 5. 3 times 1 to the 5th over 4 to the 5th, that sort of thing. Okay. And then I'm doing 1 minus r, our common ratio. 1 minus r, our common ratio is what I'm multiplying by over and over and over. In this case, it would be 1/4. So we have all this information. Let's take a look at some math here. Our first term, 3 times 1/4 to the 5th power. 1 to the 5th power is 1 times 3, 3. 4 to the 5th power is just 4 to the 5th power. On bottom, we're doing 1 minus r, 1 minus 1/4, right? 1/4. So that's 4/4 minus 1/4, 3/4. So I'm back to this thing. Here's the top part, A1. Here's the bottom part, 1 minus r. If you're dividing fractions, you multiply by the reciprocal, right? I flip it and bring it up. The 3's cancel. That's easy. One of the 4's will cancel. So this 4 will cancel with one of these 4's. That's 5 4's right there. And I'm left with 1 over 4 to the 4th, which is 1 over 256. Okay? If you add up all the terms, starting from the 6th term, forever, that series, that sum, is going to approach or get close to, or is going to be 1 over 256. Okay? Miss Kennedy has more notes in there, and then there's a book, and then there's that crazy thing called the internet that you can look up and get some additional resources. But here's some problems I want you to try. That's the suggested stamp. Go through, do the ones you can do. If you think you have nailed some section, then don't do that section anymore. Move on to the next section. But become familiar with this for ACT prep, SAT prep, college entrance exams, whatever the case may be. Calc 1, you need these kind of skills. So I gave you the problems, the even ones I want you to upload. These are just some ones to try, some odds, so you can check your answers in the back of the book. Check everything else on the to-do list, where time is running away from us here. We're running out of time, but keep staying vigilant with this stuff. Stay safe. Keep your mind sharp, and I will see you guys on the flip. Possibly.